Welcome to our Computer Science 4411 term project presentation. Today we will be presenting our system study on Oracle Autonomous Database Warehouse, which is the first autonomous database.
To begin, we will present to you our background and significance concerning autonomous databases. Database management systems, or DBMSs for short, have been widely used ever since they first gained popularity in the 1960s. From allowing programmers to efficiently operate databases to easing the way in which consumers access information, they have a wide range of applications. Due to their increased productivity and performance attributed, DBMSs have become an essential part of many aspects of society. And as new implementations are constantly pushed forward, they have been increasingly complex with endless features and functions being constantly added. Consequently, the demand for manpower to create and maintain these databases has also increased. The combination of this growing intricacy alongside the requirement for human interference constantly poses a major dilemma for database administrators. This hurdle can be overcome with the use of autonomous databases. The goal of an autonomous database is to remove the need for human intervention by implementing machine learning to perform all tasks involved in deploying, developing, and maintaining this database. As a result, the cost, effort, time, and complications associated with DBMSs are significantly decreased. In 2018, Oracle released the first completely autonomous DBMS, known as Oracle Autonomous Database Warehouse, or OADW for short. This is the software we will be focusing on for this project. There are three main advantages OADW provides, which entices consumers to choose this autonomous DBMS over traditional ones. First, OADW is completely self-driving. Users simply denote the desired output, and the system handles the rest, from provisioning and security to backups and database recovery. Number two, OADW is smarter. The system is able to automatically handle efficient index creation, optimize index configuration, as well as regular database tuning via machine learning algorithms. It is also able to accept both OLTP and OLAP workloads to maximize flexibility of usage and provides a more secure environment compared to a manual DBMS. And last but not least, OADW is more reliable. Some of the features that enhance dependability include the ability to automatically restore from physical failures, rewind data to any point in the past, back out user errors, etc. As the demand and preference for autonomous software increases, these functionalities bring OADW ahead of the game against manual databases.
Project goals and objectives. Our study of the Oracle Autonomous Database Warehouse hoped to investigate and evaluate the following areas: machine learning for data optimization and data sciences, graph analytics, which included the automated graph modeling feature, as well as exploring data relationships, self-service data management, which provides data manipulation capabilities, as well as pattern recognition and data insights. And finally, data protection and security, how the automated security, backups, and patching are handled within the Oracle Autonomous Database Warehouse.
Next, I'll be going over the methodologies and approaches that we used to achieve our project goals and objectives. We collected and leveraged a wide variety of resources and tools for this case study. Oracle provides a large amount of reading materials, including information on both the general Oracle Database website and the specific Oracle Autonomous Database Warehouse website, as well as the Oracle Autonomous Database Strategy document. We also made use of both live and asynchronous tutorials, including a live Oracle walkthrough, and follow-along styled labs and tutorials through our Oracle Autonomous Database Warehouse account. In-depth documentation of the various features and functionalities of the Oracle Autonomous Database were also made available to us. We will accomplish our project objectives through both research and testing of the Oracle Autonomous Database. For machine learning, research into Oracle's approach towards database optimization was done, specifically the tasks that were made autonomous by the database. We also looked into the machine learning functions available for data science applications by building machine learning models on a test dataset and evaluating their ability to effectively classify samples based on available attributes. Next, graph analytics features were used to explore and visualize relationships between features in our test dataset in order to evaluate the effectiveness of the in-house functions provided. Oracle Autonomous Database also offers a variety of self-service data management tools, which we compared with manual data exploration. And finally, to evaluate data protection and security functions, we researched the security protocols and measures set in place by the database. We also ran security assessments, following scheduled tasks that mimic real-life use scenarios. We'll be testing the various features and functionalities of the Oracle Autonomous Database using the Palmer's Penguins dataset. This is a publicly available dataset designed for data exploration and data analysis practice. It contains 344 samples and 15 variables, making it a suitable size for this case study. A subset of the data is shown on the screen.
Functionalities and features. The main feature that sets Oracle Autonomous Database apart from other data management systems is the fact that it is autonomous, meaning necessary tasks to maintain the database can be performed without human intervention. We decided to explore and test the main functionalities that make Oracle Autonomous Database Warehouse autonomous. So first we'll go over the database optimization by machine learning. In a traditional database, database administrators spend time monitoring database usage diagnostics to maintain the following tuning-related tasks: index performance, managing table space storage, and creating table partitioning to enhance performance. The issues with this traditional approach is that it is a very time-consuming and error-prone process that relies on the database administrator to constantly identify areas of improvement, determine when additional resources are needed, and to take the database down for maintenance. As databases grow larger to accommodate more stored data, optimization becomes increasingly more important, and the tuning required also grows as a result. This highlights the importance of an automated solution to ease pressure from the database administrators who must spend so much time tuning the database. Oracle Autonomous Database Warehouse handles this issue by using machine learning. Oracle provides several machine learning algorithms that are applied in the background as scheduled jobs to learn from usage statistics generated by the database with the goal of enhancing performance for the database. By using these statistics as an input, these algorithms can learn and identify common patterns for improved efficiency, making fault predictions, and handling potential errors derived from the database. The advantage of this machine learning is that manual input from the database administrator is massively alleviated in areas regarding provisioning, configuration, scaling, error detection and resolution, as these algorithms can autonomously check for issues constantly and test improvements to optimize the database. An example of how these machine learning processes are used to optimize the Oracle Autonomous Database is through automatic indexing. The way automated indexing works is by using machine learning algorithms to routinely check the workload of the database to identify when missing indices could improve performance, as well as detect when old indices should be replaced due to deteriorated efficiency. After identifying which tables can be improved, the table's statistics are referenced for commonly used SQL statements to construct test cases for evaluating new automated indexing candidates and determining whether they improve or regress performance for such workloads. These automated indexing candidates are generated by the algorithm as the missing indices from the tables that can improve some sort of performance. These are generated initially as invisible to the query optimizer before their enhancements have been validated. To validate their performance, they are tested against the SQL test cases to ensure they improve overall performance of the table by comparing query plans against the current configuration of the table. If they are found to increase overall performance, then the automated indexing candidate is fully deployed and visible for use by the database as a B-tree index. Machine learning for data science. Adjacent to the management of the database, another crucial component is the actual application of data within a database to fuel data science-related workflows. Being able to easily extract insights, perform query operations, and identify outliers from the database are integral parts of the data science process and are typically done manually by data scientists in the traditional database. Oracle Autonomous Database provides a streamlined approach for data science processes, including data exploration, data preparation, and data modeling. This is once again possible through the use of machine learning algorithms, where they are able to do the heavy lifting when it comes to handling these tasks and providing data scientists with an opportunity to focus on their results from the data rather than figuring out exactly how to extract analytics from the database. An example use case for this would be creating a predictive model from a dataset to predict future outcomes on similar sets of data, which could range from classifying data rows based on specific factors or determining an average value for a column based on historical existing data. Oracle Autonomous Database provides exactly this type of functionality through an experiment tool called AutoML, where a user is able to define a table from the database as an input source, denote which column from that table they would like to predict as an output, and through which predictive method they would like to choose between classification or regression. In our system study, we wanted to take advantage of this functionality to create a model that could classify penguin species correctly based on samples provided by the Palmer Penguin dataset. After successfully running an experiment, you are shown a leaderboard that ranks the various machine learning algorithms which could be neural networks, random forests, support vector machines, etc., and how accurate they were in predicting your target column, as well as how important each column from the table was in determining the prediction. In our case, the experiment decided that the neural network algorithm was the highest accuracy model for us, and that Coleman length, Flipper length, and Coleman depth were the most important columns for predicting our penguin species. You can also save these predictive models from the leaderboard and deploy them for use in code notebooks. After deploying the models, you can then use them to generate SQL tables using the predictive model to fill in the columns based on input data. In our case, we used the model to generate a table comparing the predicted species against the actual species column from each row of the Palmer penguin dataset with a 100% accuracy. Thus, we were successful in using a predictive model to replicate our Palmer penguin dataset. The entire process was incredibly easy and only required us to write a single SQL statement, which was basically using the model to generate a table. This just goes to show how much autonomous means can simplify the data science process by making it way easier to extract analytics from the database.
Now I'll be talking about the various graph analytics functions and features that we evaluated. As more and more data is being generated, analyzed, and maintained, Oracle Autonomous Database is able to support users by providing convenient yet effective methods to capture important details of the data visually. And first is through in-house visualization tools. These facilitate relationship-based analysis of data without transferring data entities to external platforms. The user-friendly interface enables graph features for ranking, clustering, and mapping out patterns in a data without the need of extensive coding or direct manipulation from the database user. The applications of these quick visuals include the identification of anomalies and trends, classifying groups, and discovering associations in a data. They are also beneficial for professional charts to help in the dissemination of information. The graphing platform supports a wide variety of chart types and customizable parameters. The user just has to enter an SQL statement to indicate the table containing the attributes of interest, and Oracle Autonomous Database will handle the rest in creating these graphs. Oracle Graph Studio is another platform included in the Autonomous Database that enables further customization of created visuals. Users are required to use relational query language-based commands to draw graphs using their data. Again, there's a wide range of graph types to select from, and both of these features also provide tabular views of the data and the option for exporting graphs and tables. The next set of functions that we explored are those related to self-service data management. These involve data exploration, which is a fundamental step for data usage. Current procedures to convert data across various formats or to identify and manage anomalies often require extensive user involvement, are time-consuming, and vulnerable to human error. Oracle Autonomous Database supports in-house direct manipulation and investigation of data from the database, granting both increased convenience and security for database users. Oftentimes, the data is not immediately usable for queries and other investigations without first doing data manipulation. Certain configuration parameters are necessary for performing a variety of actions on a database. Some of these are either not set previously or are lost when the data is being transferred into the database. Oracle Autonomous Database provides an SQL workbench for manipulation of tables and data values. As seen on the slide, the interface provides an SQL query box for those with familiarity who may prefer to work from a coding environment. There is also a less complex coding window available for users without SQL knowledge, and this view provides a more accessible option to manipulate the data. Some features available for customization include setting up attribute details and identifying keys, indexes, and constraints. Investigations can be submitted as jobs to run automatically without human interference, and this effectively improves productivity and efficiency. The next feature is the Data Insights platform, which makes use of a variety of analytic functions built into the Oracle Autonomous Database to capture important details from the data. The page will highlight anomalies and unexpected patterns in a pairwise analysis of attributes. Users are able to select their column of interest, and the function will automatically generate a series of bar charts that displays values of the selected measure across all pairs. The page will also generate estimates of expected values of the measure to use as benchmarks, which we can see as the green lines in the plots. In comparison to external platforms for data exploration, such as RStudio, this Oracle Autonomous Database function is much more user-friendly and efficient. Achieving similar results using external platforms may require greater amounts of memory and greater time costs.
Now let's dive into data protection and security. Database security refers to the preservation of data confidentiality and integrity. It is very important for a database to have tools and measures to enforce this security and prevent data breaches, as they can contain very sensitive information. Oracle provides a number of data protection tools. Number one is encryption. Oracle Autonomous Database applies always-on encryption to the entire database, backups, and network conditions to ensure that data is protected whether it is at rest or in transit. There are unique encryption keys for each database and any backups or clone database, which are secured in a secure key store on the same systems that support the database. Number two, it has data access controls. Oracle allows specific controls for specific users, ensuring that the data is only accessible to and edited by those users. The parameters and controls that each user has can be set up and edited as needed to change their parameters and their controls. This is a very good feature to have, as you can prevent certain users, such as clients of the company, from accessing any confidential information. Number three is security assessments. Oracle provides an integrated platform known as Oracle DataSafe to assist in identifying and protecting any sensitive data. The other big feature I wanted to talk about for security was data activity monitoring. Users have the option to set alarms to receive direct email alerts when suspicious activities are detected in real time. This also provides a lot of flexibility because you can edit any of the parameters for the alarms and measure the activity metrics in the DBMS monitor. Users can specify the statistic to quantify, for example, the rate, sum, or maximum value of a certain attribute, and edit other fields as needed, such as the threshold value and the delay before the alarm is triggered. Security reports are also automatically generated for monitoring. In databases, backups are a critical component to maintaining the reliability of the data. A backup is the process of backing up the database's software's operational state, architecture, and data so that the database can be recreated in case of corruption or loss. In a traditional database, backups must be requested manually by the user. In Oracle, automatic backups are kept for 60 days and are automatically done, with daily incremental backups, weekly incremental backups, and bi-monthly full backups. And as you can see in the screenshot here, all the backups are recorded, and if needed, you can restore to any backup you would like. Patching is the process of implementing patches, which is a set of changes to the database or data with the goal of updating, fixing, or improving the system performance, which includes fixing security vulnerabilities and bugs. In a traditional database, patches are installed manually by the user, and it is very time-consuming and a tedious task. In Oracle, this is done automatically with no downtime, and the database can be used while patching occurs, as it can run in the background. At the same time, you can also monitor upcoming scheduled maintenance, including patching, so you can schedule when you want the patching to occur. You can see in the screenshot here all the patches that are occurring. For this specific screenshot, during our database, there was no patching that had occurred at the time, but this screenshot would show you any patches that have been implemented if it were to do so. Now let's talk about the features and functionalities of database performance evaluations. First, let's talk about job scheduling. This is when functions such as backups, database maintenance, alert emails, etc. are automatically set up as jobs, so you can overlook the statistics of these jobs and survey them. Oracle evaluates these schedules jobs and implements an effective schedule to complete these actions. The screenshot on the slide shows an overview of all these scheduled jobs in case the user wants to review these. Moving on to performance hubs, Oracle provides you an overview of the Autonomous Database's performance through the Performance Hub to get a quick glance or in-depth report of various evaluations of the database's performance. Users can get summaries of the measures and active session monitorings for the week, as shown in this screenshot below. The Performance Hub also displays ADDM tasks, which are reports from the Autonomous Database of the analyzed data captured by the Automatic Workload Repository. These examinations are used to determine possible performance problems in the Autonomous Database and aid in further modifications to optimize the performance. This screenshot is an example of an ADDM task, and from it you can see everything that will be provided, including what the issue was, its impact, etc.
Through this system study, the importance and effectiveness of autonomous databases were made extremely evident. Even without having looked into all the functionalities and features of Oracle Autonomous Database Warehouse, it was extremely clear why autonomous databases are getting so much popularity in today's society. From the involvement of machine learning to customizable graphing, protection, and data management, the advantages of an autonomous database in comparison to a traditional one are undeniable. Thank you so much for listening to our presentation.